Let us leave all the theories behind and learn what is hypothesis test with a practical scenario here. Jack and Jill are two friends. They sell notebooks. The notebooks that they sell is profitable and they are quite happy about it. They help each other on their business and they are quite successful in the already competitive market because they perform various types of tests to improve their marketing. One day, Jack brings up an idea that if they sell the ballpen along with the notebook, their total sales would be affected. Jill thinks the other way. Jill thinks that their sales wouldn't increase or decrease. He simply thinks that there is no relation with the selling of the notebook and selling of the combined packet of notebook and a ballpen. After some discussion, they think of doing the hypothesis test to test which of their decision is more valid and suitable for marketing. This is called hypothesis testing because each of them formed their own hypothesis about the sales and started testing it whether their statement is true or false. The first step of hypothesis testing is stating the null and alternative hypothesis statement. So what is null hypothesis? Null hypothesis is the hypothesis of no difference. In other words, it is a hypothesis which suggests that there is no change and every treatment gives the same or similar result. Or when we form the null hypothesis, we can say that there is no difference between two measurements or two treatments are creating the same results. Note that the null hypothesis often contains the is equal to sign and is denoted by as not. In the hypothesis experiment of Jack and Jill, if we denote the average sales of the notebook by mu1 and average sales of the notebook and ballpen combined packet by mu2, the null hypothesis can be stated as there is no difference between the sales of the notebooks alone and sales of the notebook and ballpen combined, or mu1, which is the sales of the notebook, minus mu2, which is the sales of the notebook and ballpen combined, is equal to 0, or the sales of the notebook is equal to the sales of notebook and ballpen combined. mu1 is equal to mu2. So we can redefine the null hypothesis statement as not is mu1 minus mu2 is equal to 0, or the as not is mu1 is equal to mu2. Alternative hypothesis is opposite of null hypothesis. It means that the treatment creates different results or there is some change between two sets of data that we are measuring. Note that the alternative hypothesis often contains the not equal to sign and is denoted by HA or S dash. In the hypothesis experiment of Jack and Jill, if we denote sales of the notebook by mu1 and the sales of the notebook and ballpen combined packet by mu2, the alternative hypothesis can be stated as there is some difference between the sales of the notebooks alone and sales of the notebook and ballpen packet combined, or mu1 minus mu2 isn't equal to 0, or mu1 minus mu2 might be greater than 0, or mu1 minus mu2 could be lesser than 0. That means either mu1 could be greater than mu2 or mu2 could be greater than mu1. We can also state the alternative hypothesis as the sales of the notebooks isn't equal to the sales of notebook and ballpen combined packet, or mu1 isn't equal to mu2. In the symbolic form, alternative hypothesis statement can be stated as shown here. Let us learn some more points to remember. First of all, let us look to one-tail or two-tail test. While stating the alternative hypothesis statement, if we say that there is some difference between the sales, we do not particularly mean whether sales of the notebook is higher or sales of the notebook and ballpen packet is higher. It may go any way. In that case, we do a two-tail hypothesis test and say that the alternative hypothesis or HA or as not as mu2 is greater than mu1 or mu1 is greater than mu2. So here, if we want to test whether the sales of the notebook is higher than the sales of notebook and ballpen packet, or if we want to test whether the sales of the notebook and pen is higher than the sales of notebook alone, in that case, we do the one-tail test. So the summary is, if we state the alternative hypothesis as the mean of some dataset is greater or lesser than mean of another dataset, then this alternative hypothesis statement would be good for one-tailed t-test, meaning the hypothesis test is measuring whether one mean is greater or lesser than another mean. Now let us look about population and sample. Now let's suppose that Jack and Jill started sales from January 2019, and each day to some customers they sold the notebooks, and to some customers they sold the notebooks and ball pen packets. So the entire sales of the year 2019 is their population. Population is the entire set of data from which we are trying to make a logical conclusion. But often it is difficult to gather all the data because of the various factors like time and cost constraints. So we can take a part of the population which is called sample. The method of selecting the sample from the population is called sampling. There are various ways of sampling from the population from which we can study under the separate topic of sampling. Note that sampling or the sample must always be random and bias-free. In the case of Jack and Jill, to make it random and bias-free, Jack and Jill randomly selected the month by pulling one among the 12 balls without looking into the container. They found the ball of May from the randomized balls. Now Jack and Jill took the recording of all the sales made in the month of May. So all the data of sales of the May is the sample here. Or in other words, Jack and Jill had the randomized sample. In this case, the sample, that is sales in the month of May, and selling of the object, notebook and ballpen combined packet, are randomized because these are not affected by the intuition of both Jack and Jill. One thing to understand is, in hypothesis stage, we are not testing about the sample. We are testing the whole population by applying the test in the randomized sample so that the result of the hypothesis test gives us the information about the whole population. Now we know that hypothesis test is an experiment, right? In doing any experiment, there might be many chances of errors. Let us study what kinds of error we may encounter. The first one is type 1 error. Suppose in reality there was no difference in the sales of notebook and the combined packet of notebook and ballpen, but somehow with hypothesis test, Jack and Jill, or say we came to a conclusion that there is a difference in the sales, or say sales of either the notebook or the combined packet of notebook and the ballpen is greater. In this particular case, the null hypothesis was correct. But suppose we rejected the null hypothesis. So we committed an error. Type 1 error is the error when we reject the null hypothesis even when it is true. There is always a possibility of drawing a wrong conclusion. So there is always some chance of getting the type 1 error. Type 2 error is failing to reject the null hypothesis even when it is false. This type of error is also called beta error, and the type 1 error is also called the alpha error. So we just learned about the alpha and beta errors. The next step of the hypothesis test is the selection of the level of significance. So what is meant by the level of significance? Level of significance or alpha value is the maximum risk threshold or maximum probability for doing the type 1 error. We want to limit the probability of type 1 error to no more than some small percentage, such as 5% or 1%, which is the alpha value. Alpha is equal to 0.05 means there is a probability of rejecting the null hypothesis, which states that there is no difference even when it is true as 5%. We can increase the value of alpha based on our level of risk tolerance. If we have higher tolerance for error, we can increase the value of alpha, and say if we have lower tolerance, that is, if we want our measurements to be very precise, we can decrease the alpha value. Generally, alpha value of 0.05 or 5% is most commonly used and could be high or low based on the industry or project standards. We already learned that alpha is also called the level of significance. So, Now here I want to present a traditional guideline for choosing the level of significance as follows. When you are doing any government or political polling, generally selecting the alpha value as 0.1 is popular. The alpha value is generally selected as 0.05 for the research projects, and in this course too, we will be selecting the alpha value as 0.05 for all the examples explained in this course. We generally select the lower level of alpha value as 0.01 for the quality assurance and quality control purposes, because the data and the result in such scenarios should be very precise. The next step of the hypothesis test is selection of the appropriate test statistics. Now this may sound a little difficult job for many students, as this is not an easy task on the first run. The next step is stating the decision rules. The decision rule states the conditions under which the null hypothesis will be either accepted or rejected. The critical value is the value that divides the non-reject region from the reject region. Now this might seem a little hard, but I will try to explain it in much simpler terms here using another term, p-value. P-value is the probability of obtaining a value of the test statistics that is more extreme than what is observed, given that the null hypothesis is true. If the actual value of the statistic is too far from its expected value, then the p-value will be very low, indicating that the null hypothesis is unlikely. Now for some students, these two statements can be somewhat difficult to understand, so I'll try to make it more simpler here. If the statistical test returns a p-value that is lesser or equal to alpha, we reject the null hypothesis. If the p-value exceeds the alpha, then we fail to reject the null hypothesis. Some of you might have the question, what is the alpha value and the p-value? The alpha value is generally 0.05 for all the examples in this course and for all the research purposes, and the p-value is automatically generated to us by the Minitab. So we do not have to worry about what is p-value and how can we calculate the p-value, because Minitab will automatically calculate the p-value for us. So we have to compare between the p-value and the alpha value. The range of the p-value is from 0 to 1. Somewhere right here, there is an alpha value. Suppose the alpha value is set at 0.05. Now after doing the calculations in Minitab, if our p-value is greater than 0.05, then we accept the null hypothesis. In other cases, we reject the null hypothesis if our alpha value is lesser than 0.05. So 0.05 or the alpha value is the cutoff point to either accept or reject the null hypothesis. Let me make it more easier to remember for you. When the p-value is low, let the null go. That means when the p-value is lesser than 0.05, then you should reject the null hypothesis. When the p-value is high, the null fly. That means we accept the null hypothesis when the p-value is greater than 0.05. Okay, then the fourth step is computation of the appropriate test statistics and making the interpretation of the decision. Suppose we have the following data of the sales of the notebook and the combined packet of notebook and ballpen sales for the month of May. The next step is computation of the appropriate test statistics and interpret the decision. The same data of Jack and Jill's notebook and ballpen sales can be copied into the Minitab. This particular example is best suited for two-sample t-test. We can perform the two-sample t-test with the help of Minitab. I will explain how to perform the two-sample t-test in Minitab in much depth later in the course, but for now we can go to the stat, go to the basic statistics and two-sample t-test, and then you can perform the two-sample t-test after following the lesson on the two-sample t-test, and then you click the OK. Here in this result 2 produced by the Minitab, you see that the mu1 is the mean of notebook sales and mu2 is the mean of notebook and ballpen sales. The difference is of course mu1 minus mu2, and we have assumed that the null hypothesis is there is no differences between the means, and alternative hypothesis is there is some difference in the mean, or mu1 minus mu2 isn't equal to 0. Now the one thing that we must observe is the p-value here. p-value is 0.00, which of course is lesser than the alpha value, which we said at 0.05 at 95% confidence interval. Now, do you remember our rhyming formula? When the p-value is low, let the null go, or when the p-value is high, the null fly. From the Minitab test, we got the p-value as 0.00. Now 0.00 is lesser than 0.05, which is the alpha value. So when alpha is lesser than p-value, we should reject the null hypothesis. We reject the null hypothesis means we accept the alternative hypothesis. Now the alternative hypothesis was there is some difference between the sales of notebook allowance and the sales of notebook and ball pen packet, or mu1 minus mu2 isn't equal to 0. Or sales of the notebook isn't equal to the sales of the ball pen and notebook combined. Mu1 isn't equal to mu2. So we accept this alternative hypothesis. That means there should be some difference between the sales of the notebook and sales of the notebook and ball pen combined packet. This is just the summary of hypothesis test and how we carry out the hypothesis test. In fact, we will learn it in much easier and detailed manner in the next lectures.